Good morning, everyone. Today, I will present our ongoing study, one of our ongoing study regarding the collaborative research project with Project SINAG. Next slide, please. So here are the outline of our presentation, framework of the diagram, the objectives, introduction, and the sample model, application code, and user interface. So here, the data from the project SINAG will develop a numerical model and also a multi-physics model of a solar PV panel. And then we will develop a DUSTSIMULCAST application from the COMSOL Builder application. So the objectives, the study aims to develop a user-friendly COMSOL application named DUSTSIMULCAST, design the geometry of a solar PV panel and develop the multi-physics model, determine the parameters from the data of Project SINAG and develop the numerical model, and finally evaluate the accuracy of the COMSOL application. For the introduction, COMSOL Multiphysics is a multi-purpose simulation software that allows the modeling of many devices and processes in the areas of research and engineering. Modules and add-ons can be used to complement the use of the software and allow access to the new features. It is advantageous when working in more specialized areas of engineering and research. When working with COMSOL, the user's workflow is the standard one in multi-physics modeling. So, like defining the geometry of the model, the properties of the parts that constitute it, and changing the values related to physics phenomena. In the end, the users obtain an accurate simulation of the generated model along with information in the form of reports and graphical visualization. Investigating the particle deposition mechanism on the solar PV module surfaces is beneficial to predict the dust accumulation amount and determining its impact on the solar PV performance. The dust accumulation impact on the PV module performance has also attracted increasing attention. Although solar PV panels are widely commercialized technology, no existing technology can tell its performance in the presence of particles and dust. Next slide. The main goal is to make a fully featured dust accumulation in solar PV panel simulation software named DUSTSIMULCAST that additionally allows users to change the geometry layout, import and export data files, and perform simulations for multiple parameters being varied. It will enable automatic adding or deleting of layers in the geometry, calculation of results for any parameter sweep, and comparing the simulated result in the imported experimental results. It can also be used with a COMSOL model builder to couple any additional physics processes to the solar PV panel model. So this is the example of a geometric a multi-physics model from the COMSOL Builder app. Next slide, please. So this one is just an example of an application code for the development of the multi-physics model. And lastly, this one is the example of the user interface where the user can just click for the solar PV performance and then click which parameters you need to use or you want to use, for example, the wind speed, the humidity, or the particle size that you want to input and create or develop or to see how it will your solar PV performance in terms of graphical representation. So our target is to fully develop the version of the DUSTSIMULCAST app, apply for the copyright, and share and make the app available online. That's all. Thank you. So here is my email address if you want to collaborate in our laboratory, simulation, measurement, and modeling laboratory. Thank you.